Here is a video on solving systems of equations. So a system of equations, you can go ahead and read there, is a set of two or more equations containing two or more variables. On the graph, when we graph the system and the two lines intersect, then that is going to be the solution for the system. So example 1, we're going to give you a system, so there's two equations there, and a possible solution written as an ordered pair. And we want to verify if this solution holds true. So this is my x and then my y. So I'm going to start with the top equation, x minus 3y equals negative 8. And then we're going to substitute the ordered pair in for x and y. So we have 1 minus 3, and we're going to replace that y with 3. And now we're going to simplify the left and right side of the equation. So 1 minus 9 equals negative 8. Negative 8 equals negative 8. This is a true equation. So far, it's looking like it is the solution. Then we go to the second equation. 3x plus 2y equals 9. And we substitute again the ordered pair in. So we're going to place the x with 1. We're going to place the y with 3. And then we simplify the left and right side. 3 times 1 is 3. 2 times 3 is 6. 3 plus 6 is 9, equals 9. So this is true. So what that's telling us is the ordered pair 1, 3 is yes, a solution. Here's example 2. Same concept. We want to substitute the ordered pair into both equations and see if it holds true. So the top equation, the bottom equation. So if you want to pause and try it on your own first and see if you get the same answer as me, go ahead and do so. So we're going to replace the x with 5, and we're going to replace the y with 3. And then simplify. 6 times 5 is 30. 7 times 3 is 21. 30 minus 21 is 9. When we look at that equation, 9 does not equal 1. This is false. So we don't have to take this equation and substitute in for the ordered pair because we already know that that first equation, the ordered pair, is a false statement. So 5, 3 is not a solution. Example 3. Now it says use a graph or a table to solve the system and then check your answer. So we're giving you a system of two equations and we want to graph them and see if they intersect. So I'm going to start with this top equation here. And I'm going to go ahead and solve it for y. So 2x minus 3y equals 3. Why we do that is we want to get it into slope-intercept form. So I'm going to go ahead and subtract 2x from both sides. And then divide both sides by negative 3. And then simplify. So we get positive 2/3 x minus 1. So that'll be our top equation that we're going to substitute in. So y equals 2/3 x minus 1. The bottom equation, we also want to get it into slope-intercept form. So y plus 2 equals x. Bring that 2 to the right, so subtract 2 from both sides. So that'll be our bottom equation in our table. And now what we want to do is we want to find those ordered pairs. So one way is you could substitute numbers into the domain. So I'm going to start with this bottom one. So -1 minus 2 is -3. And then substitute 0 in. 0 minus 2 is -2. 1 minus 2, -1. So our ordered pairs are -1, -3, 0, -2, and 1, -1. Now we've done this in previous lessons, so I'm just going to go ahead and give you the solutions to this top one, -1, comma, -1 2/3, 0, comma, -1, and then 1, comma, -1/3. The other way is you can notice that this is going to be your slope, and that's your y-intercept. And again, this is going to be your slope of 1 and your y-intercept of -2. So that's the other way to do it if you didn't want to create a table. What we're going to do next is we're going to go ahead and graph those two lines. So I'm going to zoom in here. All right, so let's graph that top equation, the one in black. Remember the slope was 2/3. And the y-intercept is -1. So we go to -1, and then we're going to go up to right 3. Up to right 3. Or down to left 3. And that'll create our first line. Then we graph the second equation. The second equation, its slope is 1, or 1 over 1, and then the y-intercept was -2. You can also just graph the ordered pairs that we found in the table. So y-intercept is -2, and then we go up 1, right 1, up 1, right 1, up 1, right 1. And notice right there is where the 2 points, or the 2 order equations, intersect at the ordered pair 3, 1. So the solution is in the blue, 3, 1. If we wanted to check to see that it is truly the equation solution for the system, we would go back up here and do these steps. We would substitute the ordered pair into both equations to see it's true.